tardes. Esta es la conferencia Deep Learning for Everyone. La presenta la profesora Gabriela de Queiroz. Ella es fundadora y CEO de Rday. Trabaja en IBM, es científica de datos, conferencista, mentora y tutora. Entonces le damos la bienvenida a la profesora Gabriela de Queiroz.
Pronto, pode começar.
Muchas gracias. Unfortunately, I don't speak Spanish. I only speak Portuguese and English. Hopefully next year my Spanish will be good enough to present in Spanish, but so far only English and Portuguese. So I'm sorry about that. But next time I promise you to be better with my Spanish. So my name is Gabriela de Queiroz. I work for IBM as a senior engineering and data science manager. And I'm excited to be here today to be presenting my work mostly with IBM. And all the slides are going to be hosted in the URL below. So it's bit.li-rday Medellín. So you can find all the material that I'm talking today in this URL. So you probably know me because of Our Ladies. So I founded Our Ladies in 2012, and I talk a little bit about this later. And I founded a new group called AI Inclusive, which is more focusing AI. So bringing awareness around AI technologies and empower communities to be inserted in the AI area. I'm also the member of the R Foundation. I'm the only, I think, Latina in the R Foundation, which is huge. There are several people in the R Foundation, and I'm one of them. And so I kind of like call myself a data scientist, a developer advocate, an open source developer, a manager, a community builder, a mentor. So that's pretty much like what I've been doing throughout the years. So I am a combination of all those things and even more things. So I don't consider myself only a data scientist or only a manager. So I think it's a mix of like all these titles per se. So Our Ladies, if you are not familiar with Our Ladies is an organization that promotes diversity in the art community via meetups and mentorship in a friendly and safe environment. It always started when I moved from Brazil. So I'm originally from Brazil, from Rio de Janeiro. And then I moved to San Francisco in 2012, so 7 years ago. And when I got to San Francisco, I was impressed by like how much resources we have over here, and something that we lack, especially in Latin America, and in particular, Brazil, but I think it's all Latin America. So we lack this type of resource community, a safe environment, and knowledge in general, right? So here in San Francisco, it's the capital of technology. So many people doing interesting stuff, and they have resources for everything that you can think of, and like free resources. So in 2012, later in the year, I saw that there was this need to have this environment where we could feel safe and welcome. Because I started going to all these meetups, like I would go to meetups every day. And one thing that I noticed is there is no place that I can feel that I'm safe, welcome, and I can be myself. So I got to a point where, you know, what do I know that I can share with others? So I knew R. I was using R in Brazil for a few years. And then I thought, why I can't, you know, maybe I can teach R. I can help people to understand and learn R, but I want to do this in a more friendly environment, in friendly and welcome community. So that's how Our Ladies was born. So October 2012, 2012 was the first Our Ladies meetup here in San Francisco. And you, I don't know if you're aware, but you're probably aware that we had grown to all, like pretty much the main countries. And we are in over 170 cities in 47 countries. And one thing that I'm very proud about in particular is the Latin America growth of Our Ladies, because again, going back, you know, Latin America, Africa, some places in Europe, we are so underserved in terms of like resources, knowledge, and so on. So for me in particular, seeing the growth of Our Ladies in Latin America, it's such a huge win, like personal win per se. And in Colombia, we have two chapters, and we have the Bogota chapter and the Medellín chapter. And tonight is going to be the first ever Our Ladies Medellín event. So I think it's going to be after the conference or during the night. So I'm just sharing some links if you are curious to find out more about the Our Ladies Medellín. So it's awesome to see this growth in Latin America. So almost like 1/4 of like all the groups are located in Latin America. So that's huge. So thank you very much for all this involvement with the Our Ladies community. But today here, I'm going to talk about like my work at IBM. So my work at IBM, it's very unique because the whole organization, we are working with open source technologies. So everything that we do, it's open source and it's free. So anyone can use, right? So we are based on an organization called CODE, which stands for the Center for Open Source Data and AI Technologies. So we have more than 30 people working with open source. So we have open source developers. And interesting is we have in-house projects, so projects that we develop in-house, and we have projects that it's from the external community where we contribute. So examples of like open source projects contributions that we do are TensorFlow, PyTorch, Queiroz, Apache Arrow, Apache Spark, Onyx, and other. So it's very interesting and unique in that sense because we are doing everything that we are doing, it's open source. So from the inception to execution, you can follow our journey. You know, you go to the GitHub and then you can find everything that we are developing. So there is no like closed doors, everything's open door. And my team in particular, we are based in San Francisco in a beautiful building in the downtown area. So one of our goals is to build tools to make AI accessible to all. So our team in particular, it's very, very focusing AI and data. And in this picture below, I'm kind of like showing you like a data science pipeline. So every piece of this pipeline, we have some kind of contribution, either from in-house project, which is open source, or contributing to external open source projects. So as a data scientist, for example, you know, data science is still like a hot area and people are trying to break into data science. And that's something that happens. So like if you do a search for important skills for data scientists, you are going to get a list of like 300 skills that you should have, right? You should know Python, R, C++, Scala, and then Hadoop. You need to know machine learning, statistics, AI, data visualization. You need to know how to deal with structured and unstructured data. It's like a list that never ends. And you're like, okay, so you know, you want the unicorn, right? You want someone that knows everything, which is impossible. So it's very common, like if you are looking for a data science job, that they will list every possible and impossible skills that you can have, right? And in terms of like machine learning, one one issue that we have as a data scientist or someone that is trying to break into the data science world is how do you keep up with so many new technologies, new papers, new algorithms, you know? So I like to show this graph, this plot, because it's a tweet from Jeff Dean from Google, where he says, you know, that there are more than 100 new machine learning papers being published every day. So like to keep up with this, the only thing that you need to do every day is to read papers, right? So it's impossible. There is no way that you're going to stop your life and read all these papers so you are up to date, right? So then what do, right? You also, like, if you go and search on all the articles where they have the deep learning keywords, you're going to get more than 4 million results. Like, which paper should you read if there are more than 4 million results? If you look for courses, there are more than 183 million results. So at this point, you are totally lost. You're like, please, can someone help me? I want to break into this data science AI world, but I'm like, I don't know how to start. I'm so lost, right? So thinking about that, when we're thinking about that, that's why we created this open source project that I'm going to deep dive into this today. So based on all these papers and all these new technologies being born every day, we thought of like, can we break this barrier? Can we make deep learning, or can we make a place where people can find those state-of-the-art deep learning models to use? And we developed the Model Asset Exchange, which is a place for developers, data scientists, actually anyone to find and use deep learning models. So this link that I have over here is going to take you to our main web page. And if you go there, you are going to notice that we have several deep learning models. We have more than 30 deep learning models that are ready to use. And I'm going to explain why, or what do I mean by ready to use deep learning models, right? So we have models from all the domains. So ranging from text, audio, image, video, etc. And also we have like all these different deep learning frameworks. One another barrier is when you go into the deep learning, there are so many frameworks. It's kind of like similar when you are getting into data science. It's like, should I use R? Should I use Python? Should I use Excel? Should I use this? So you have like different ways. In the deep learning, you have like these frameworks as well. Like you have TensorFlow, you have PyTorch, you have Keras, you have others as well. And these models that we have that are ready for you to use, we have like two versions. We have models that are ready for you to deploy in your application, and we have models that you can train using your own data. So at this point, you are like, okay, great. You have all these open source deep learning models that I can use, but what do I need to get started? Do I need to know deep learning? Do I need to know how things work in very details? And then I say, no, you know, the only thing that you need to start, it's a Docker. And even if you don't know what a Docker is, which pretty much to start, you don't have to, you just have to install Docker. If you go to the Docker website, it guides you through how to download. You're pretty much downloading an app, and that's it. So once you have the Docker container running, you know, you have like several ways that you can access the models. So again, going back to Docker, it can sound scary, and kind of like it sounded scary for me at first because I had no idea about Docker. I'm a data scientist, I'm a statistician. So Docker is like, it's like like people who are doing development or like system administrator, I don't know, something like very far away from my world. So I was afraid of using Docker at first, but in the end I was thinking through like, I only need to download. I don't need to know how Docker works at first unless I want to go further, right? So once you have Docker installed, then you can access the model. And now I'm going to guide you through ways for you to access the model. And if we have time in the end, I can probably show you a few ways of accessing. So the first one is, let's get an object detector, which is one of the most popular deep learning applications, which is you have a picture. In this case, I have a dog and a cat. And I'm going to use this image as our input to this model, and I'm going to localize what are the objects in this image, and I'm going to identify. So like in this example, I'm localizing. I see that there are two objects. There is, and then I'm labeling. So I'm saying, oh, this object is a dog with 96% of probability, and this is a cat with 95% of probability. So that's how the object detector works. As an example, and I'm going to use object detector because it's an easy model for us to follow and understand how it works. So if you go to the web page and click on object detector, you're going to see several informations on that page. So first, you are going to see that this model is deployable and trainable. So as I mentioned before, deployable can means that you can deploy in your application. And trainable means that, you know, let's say I have some data that I want to train my model on. You can use this model, the object detector, to train, use your own data. And you have a variety of ways of accessing, and I'm going to go through this right now. And again, it will probably sound too much at this point, but all the slides and all the material that I'm talking today, I'll be sharing. It's on the URL on my slides, so you can always go back and then try yourself later. Okay, so once you go to the website, there is the first one, which is the Get This Model. The Get This Model, it's going to take you to the GitHub. So everything that we do is developed on GitHub. And why that? There are several reasons why we should use GitHub, right? So one, it's like everybody can see what we are doing. The second is you can drill down, you can go into the code and see everything that we are doing. And then you can fork, you can clone, and then you can do whatever you want. So it's a way for the community to see and reuse what we are doing. So you can go to the GitHub repo, and then you can see every little thing that we are doing, all the scripts, all the, if there is a notebook, all the application, everything under the GitHub. Again, going back to the deployment option, you can deploy using different ways. One interesting way that you're probably wondering is like, okay, now that I have a Docker container, how do I run this? So you can run locally. You don't need to have internet running, only Docker and a few command lines. So in the same web page, you can try to use this model via API. So even if you don't know what an API is, you can click over there. It's going to take you to this UI, which is called the Swagger UI. And again, I'm talking about a lot of like words that can be strange and weird that you never heard before. Like, don't worry, you don't need to know these words, but I'm trying to guide you through what we have. So you can later on, you can, oh yeah, I want to try this way, or I can use R, I can use Python, I can use a different language, right? But I'm going to give you all the options that you have. And the other thing that I want to mention is more and more, there is an overlap between data scientists, data engineering, and DevOps. So we are all kind of like we have some intersections. So that's why it's good to know this terminology, even though you don't know the whole thing, but it's good to know or be aware of these words. So you can talk, like, let's say you are data scientists, work with data engineers, you have to speak the same language, right? So you have to know some of their terminologies and vice versa. They need to know our world as a data scientist, statistician, research as well. So anyway, so you can try this using the Swagger API. And the thing that this UI does is I'm going to post. So I'm going to get this image and I'm going to get a prediction. That's pretty much what I'm doing. Like in this one, and I can show this. Let me do a demo because I think it's going to be easier. So if I go to the web page over here, and then I go to object detector, and then I go to try the API. So it's popping up this Swagger UI. Here it's all the model metadata, like what is the ID, what is the description, what is the label, what is the class label for this image, what kind of prediction I'm getting, and so on. But I'm more interested in here. So in this case, it's saying it's telling me, you know, the input is an image which has to be a PNG or a JPEG, for example. And we are using a probability threshold of 0.7. So let me do this, a quick example here. Let's see if I can go to where my images are. Okay, so this is the folder where I have some images. I'm going to get this image. Let me try to make this bigger so you can see. So like in this case, I'm getting this picture, which is a picture of a kid and a teddy bear. So I'm going to open this as an input and I'm going to execute this model. So this model is trying to detect what are the objects and the labels. So it's giving me back and it's giving me back a JSON response. So it's saying, you know, I can find two objects. I can find the object, which is a teddy bear, and I can find a person. And here are the probabilities for each image or for each object. So that's one way for you to access this API. Let me go back to the presentation. So the other option that you can do is to use a Python, for example, a Python script. So with like a few lines of code, and I also have a notebook to show you. Oh, I think, let's see, because I had some issues. No, now you can see my web page. So I have a notebook where I'm using some, you know, Python script, but here's the thing that I'm doing. I'm using a different model, but I'm trying, this is the picture that I was showing before. So I'm using this picture, and in this case, I'm doing object detector as well. So what I'm doing is like, I get this image as input, and I'm trying to see, can we localize what are the objects and what are the labels? So I'm using a different way of accessing this API through a Python notebook. So it's saying, you know, great, we have this baby and this teddy bear, and here's the probability. So the model is identifying both objects. So this is a Python notebook that I was playing around, and the code here, it's a little bit longer just to show the image, but the code itself to show the predictions, it should be 3 or 4 lines. Let's go back to the presentation. So you can do Python, and here's a notebook that I'm sharing with you. My favorite option for sure is when I have an R code. So I do the same thing. I'm calling this API endpoint, and I'm saying, you know, here's the image, the baby bear image, provide me the predictions, and it's going to give me predictions. So this is R, and I'm providing this, this code as well, so you can play around. Another favorite option of mine is the web app. So like, let's say, again, you have no idea how these things work, but you just want to try out. And then the web app I would say it's a friendly way of accessing. So let me go back here. So here on the web page, you can go try the web app. It's going to pop up this web app. And what we are doing, let me explain this first. What we are doing is there is a model running in the background, right? It's already trained, and then we are inputting this image. And then what we did here is we created an interface for you as a user to use. So like, I'm not doing any coding at all. I'm just trying to see, what does this model do? I want to understand what this model does. So I'm coming over here, I'm getting the same picture, and then I'm submitting this as an input with this threshold. And then what it's saying here, again, it's locating two objects, and it's saying this is a person with this probability, this is a teddy bear with this probability. So it's just like a UI, it's showing all the labels that it has found. If I increase or decrease, you can see that this model is saying this is a bench, but the probability is very low. So this threshold is very low. So I usually use a higher probability threshold, so I'm more certain of like these labels. So you can play around, you can get another picture and again, play around to see what is this model is detecting. So this is like a dog and a person. So I'm going to go a little bit further. So it's identify a person here and a dog here. So again, it's just another way for you to access. But the goal, what I'm trying to convince here is you can play around without knowing deep learning. I'm not talking what is the architecture of my model, what are the hyperparameters. I'm not talking about that. I'm more thinking like, how can I use this? I'm thinking like, oh great, I have this problem. I don't know anything about deep learning or nothing at all. And I just want to see if I can find any deep learning model for my problem. So let me go back to my presentation. One example that I had was like, let's say you are a data scientist and then your boss comes to you and say, oh, Gabriela, I have this problem that I need to solve. We have all these images that we need to process, and I'm trying to detect, let me think like a real use case. I'm trying to detect in this industry or in this warehouse, all the pieces that are faulty, that are not working well. So you could use some kind of like, so then I'm like, okay, great. So it's image. It's not like a regular statistical analysis or modeling that I have to do. It's something more like advanced. And I've never done any modeling with image. So now I'm like, oh, okay, so maybe deep learning can help me, but I have no idea how to start. So what I would do is I would go to the Model Asset Exchange and then see what are the models that I could use for my use case. So that's how I'm thinking. It's like, it's the other way around. I'll try to see what's out there with the max. And then if I want to go even deeper, I can go and try to change the parameters and everything else. So great. So I'm going to skip this, but like if you are a JavaScript person or a Node-RED person, or you want to create an IoT application, for example, you are a person that likes to play with Raspberry Pi, for example, you could use the Node-RED flow to create an IoT application. It's just another way of accessing our API. If you like to use CodePen, which is a different framework, you can also use. So we have like all these different flavors depending on what's your background, right? So the most important thing is here is like all of this is in a standardized way. So if you go to one model or the other model or the other model, we all have the same standard way of like providing this to you. So you know exactly what to expect. So what I mean about being standard is you go to the model, you have an overview. So the object detector, for example, it's saying, we have 80 different classes that we can identify. right? And then I say, oh, this model is using a deep convolution net-based model. And then I give you more example of like the architecture of the model. So I like to think about this. It's like, again, I don't have a deep learning background, but I can come over here and then I can start to learn about this, right? So we can come and then you can say, oh yeah, this is a TensorFlow model. Oh, great. What is the domain? Oh, it's vision. What is the application? Object detection. What is the framework? TensorFlow, blah, blah, blah. And then, you know, we have all this information. And then we provide references. Like, let's say you want to go deeper and you want to learn more. We provide the references for you. And the last piece, which is important if you are working with, if you are doing deep learning in your company, we know that there are some issues with licenses. We need to make sure that everything is good for you to use in your environment. So we provide all the licenses. So we can assure you that those models are good for you to use in your application, in your enterprise setting. So you don't have to worry about legal issues because we already went through this for you. So behind the scenes, how does it work? How does this all work? What is your team, Gabriela, doing? Okay, so let me guide you through because there is a lot. So we do all the work for you so you don't have to, right? So the way this works is we do a research, the team does research on all the state-of-the-art open source deep learning models to a specific domain, right? They say, you know, there is this new model that just came up and they are the state-of-the-art for this, this domain, right? So then we get this model. And then the first thing that we are going to see is, are the licenses okay for us to use? If so, the next step is we are going to see if the model is working, if the code is clean, and if there is no bug, right? And then the third piece is like, once you have all this working, we are going to wrap this in a Max framework. And then I'm going to provide you this REST API. And then I'm going to wrap this in a Docker. So it's going to be inside a container. And I'm going to upload to a Docker Hub. Docker Hub is kind of like a GitHub, but for Docker images. And then we are going to do a review and continuous integration. What this means is I need to make sure that everything is working all the time. So I have some checks that we do that it's automatic, and it's going to check, oh, is this image and is this model, everything working? If not, give me a warning or an error, right? So we have this review and continuous integration. So that's pretty much behind the scenes what the team does. So we do all this for you, again, because so you don't have to, right? And all this can take hours and days, weeks, and sometimes months for do one model. Oops. But until now, I was talking about like all the deployable models where I'm using the data that we, you know, my data, not your data, not your specific data. But there is a way, as I mentioned, for you to train your model. And I like to make this, I like if you are feeling more adventurous, because this is going to take you more computer resources, more time if you want to train your model. So if you're feeling adventurous and if you want to train your own model, you can. You can train your model using your own data. And for the object detector example, you can go to the GitHub and there is this training folder. And this training folder is going to give to guide you through step by step on how to train your own model using your own data, right? So, and we have like, again, a step by step on how to do that. So you have to collect the data, but let's suppose you already have the data. And then we are going to guide you through how to set up your environment, how to prepare the data for training, how to customize this training, how to train this model. And I make the joke here, this is the cartoon called How to Train a Dragon, which I think it's pretty much the same when you're training your model. So there is a lot of work that you have to do, you know, but in the end, it's trained and then it's a success, usually. So And then, okay, so I talked about a bunch of things. So like, let's suppose you want to get started, but you want a more material, like step by step with like very specific details. We want to go even further. We have like some tutorials. So one thing that the team is very careful about is like, we not only want to develop frameworks or like open source projects, but we want to have a good documentation, and we want to have like a good tutorial for you to follow, right? So it's like, it's a kind of like, it's the whole thing. It's like providing you resources, but also like the education piece, and then the empowerment as well, right? So we have several tutorials that you can go through in your own pace, and you can go like and go through some modules. You can skip some modules that you are not interested, and you can kind of like do your path depending on what's your goal. Another one of the favorite things that I really enjoy is, you know, you have these models running. So like, I have my cell phone here, there is a model running, and I'm going to create a web app or something running on top of these models. And what we call the code pattern is, it's ways for you to consume the max models. So one of my favorite these days is this one, which is, we have a max model running in the back, and it's going to guide you through some yoga poses. So it's going to say, you know, now you have to do a salute position. And it's going to say, okay, your salute position is good. So then let's do the next position. So it guides you through some yoga poses and recognizes those poses. So it's a fun example of application. Another one is, we have a web app where you ask questions and it gives you answer. You ask question and give you answer. This one is in particular based on a biology domain. There is another one that you can use your arms to make music. So you can also try this out, where you use your arms to make music. And you can find all the details that I'm talking right now in this max code pattern. But it's a fun way for you to explore, you know, what you can do with all those max models. Oops. And then, of course, open source projects needs the developers and your help to keep going, right? So there is no way for open source projects, like let's think about R, right? R, we have so many packages. If we need people contributing, otherwise we are going to get stuck. We don't have enough people to keep improving the packages, so we need the community to help us. So the same thing for the Model Asset Exchange. We need your help to keep this project growing. And we created this central repository where we guide you through some ways that you can contribute. So you can go to the Max Central Repo. There are several ways. The first way that I'm going to mention is, let's pretend you found a model that we don't have in the Model Asset Exchange, and you want to contribute to our marketplace, right? You can. You don't need to wait for us to find this model. You can help us with that. So we guide you through a step-by-step on how to do that. So we have this kind of like a framework, and you just follow through all the steps to wrap your models in this Docker container, and then you can publish in our website. And all this will go through a code review. So our team and the community will be there to be reviewing your code and seeing if there is anything to change or not. So contributing to open source is also a way for you to learn, right? You don't need to know everything, so you learn with others. Other ways, this is some ideas, right? So other ways that you can contribute. In some of these repos, we are missing a demo notebook, which is a IPython notebook. And we have examples on how to do that, but we didn't have a chance to create for all the mods, for all the 30 plus models. So if you go in this, I'm showing 2 screenshots over here. you know, you can see like good first issue as a label, so anyone could help. And we are providing an example. So it's pretty much the same demo notebook, but it changes a few things over and there because it's a different model. So if you are interested, you can go and contribute with these IPython notebooks. Another example, and this is my personal idea, is, you know, all this is in Python, pretty much all this is in Python. Can we do the same thing in R? Because it would be amazing for the R community to have this kind of like project. We don't have anything like this, as far as I know. So could you do the same IPython notebook, but in R, using like R Markdown, for example? Can we create the same web app that I was showing you, which runs in Python and in Flask? Can you do the same thing in Shiny app, using Shiny? And all this that I'm saying, it's possible because I already did some prototyping, but I didn't have a chance to put out there, but I know that it's possible. So everything that we are doing in Python, we can do in R. So it's going to be a contribution, not only for this project in particular, but for the R community, right? But again, this is some ideas. And if you're interested, you can open issue in the GitHub. You can find me and ask me how to do this. You can send me an email, a message, and that's pretty much it. So thank you very much for embarking this journey with me. This is a picture that I like to show in the end of my presentation, which is a project by this photographer called Peter Adams. And his project is to show the faces of the open source. So like, what are the people contributing to open source? So he has a collection of like all portraits that he invites these open source contributors to come to his studio, and he takes pictures. And I was very honored to be the first one representing the R community. So go to this website, check this out. There are several portraits from different people from different communities. Like, so it's an awesome project. And if you want to reach out to me, there is my website, my Twitter account, and my new project called AI Inclusive. So again, thank you very much. And I think we have time for questions.
Muito obrigada, Gabriela.
Muitas
Eu vou
graças.
abrir o espaço para perguntas, tá? Obrigada. Bueno, démosle las gracias a la profesora Gabriela.
Oh, I can't hear. I think you are muted. Oh, yes.
Buenas tardes. Mi pregunta va al final de la conferencia. La profesora Gabriela habla de que todo lo que nosotros hagamos en Python se puede también hacer en R. Pero me queda una duda. O sea, yo el tema de Deep Learning, sobre todo lo de redes convolucionales, he visto mucho trabajo con una librería de TensorFlow. No sé en R qué paquete, si el paquete de TensorFlow, pues claro, el tema de tensores también se puede dar en R, no lo he visto.
Tá. Eu vou traduzir. O menino pergunta que ele tem trabalhado com o pacote TensorFlow em Python e ele gostaria de conhecer se tem algum pacote em R que faz a mesma coisa ou se esse mesmo serve tanto para Python quanto para R.
Yes, so I'll explain in English, but TensorFlow works in both Python and R, right? So in the R Studio, they developed, so with Reticulate, right? The Reticulate, it's a way for you to talk between R and Python. So the TensorFlow packaging are in the back end, it's all Python. So they wrapped the functions and they made it friendly for our users because the syntax between Python and R are a little bit different, right? So you can use TensorFlow in R as well, right? I don't know if your question was more related to TensorFlow in general or this model asset exchange that I was showing you.
In general.
In general, yeah. So you can use TensorFlow with R for sure. I used to use a lot of like Queiroz in R. So Queiroz is another framework which is friendlier than TensorFlow. Usually for beginners, I would recommend starting with Queiroz, but you can do everything with R. Let's see if I have, there is a book called, and the book was, let me see if I can grab it. 1 second. Yeah, I can find over here, but there is a book that it's deep learning with R. The same, Queiroz with R, I think it's called. The same book was written in Python originally, and then they did the same in R. So also if you are starting, you can go there. And I wish I had, let's see, give me 1 more second. And if you go to RStudio, they have a whole deep learning section here. So there are interface to TensorFlow, and they have like code or tutorials that you can follow. So it's very, very good, to be honest. So they have blogs. The blogs they try to update very often. So you can see here, this was 2 days ago, right? It's talking about the TensorFlow probability, some examples. There was a huge release on TensorFlow. So the TensorFlow 2.0 was released, I think 2 months ago. So now it's running in R as well. So they try to be up to date to whatever is happening in the Python environment. They try to be up to date with the R.
Muito obrigada.
¿Hay alguna otra pregunta?
It doesn't need to be related to deep learning. It can be data science. It can be anything.
Yo este tema de Deep Learning solo lo he visto aplicado al tema de reconocimiento de imágenes. No sé si haya otra aplicación, sobre todo digamos, en pronósticos.
O menino fala, o Deep Learning, ele conhece a aplicação de reconhecimento de imagens. Então, ele gostaria de saber se tem outras aplicações, por exemplo, pronóstico ou modelos preditivos ou outras aplicações.
Tem muita aplicação interessante como... Oh, I'm speaking Portuguese. I'm so confused with all the languages. So there are some interesting applications with, like, you can forecast the weather, right? Weather forecast is one, or stock prediction. Even though I think for that specific cases, for weather stocks where, you know, you have like time series, I think deep learning are not as good as the classical statistical models. So I don't think deep learning is still like, you know, better in that particular area. For like image, for sure, for like the whole computer vision, but for like time series is one area that deep learning are still behind. Yeah, there are a lot of like text, you know, text examples, but like for prediction, I cannot think of like good examples. But there are, I know there are, but more like image and text, I would say, are the two most well-used areas in deep learning.
Y sonidos, audios.
Y en audio o son, ¿tem
Yes.
alguma?
Yes, and we have on the model asset exchange, we have some audio or sound examples. One interesting example that we don't have a use case on that, or we don't have a model, but would be, because I think like a lot of like applications that we could be using deep learning for our day-to-day example. So like in Brazil, right, we have all the issues with gunshot. Like we have gunshot, but we also have fireworks. So like sometimes you don't know if it's a gunshot or if it's a firework. So like, let's suppose I have a model running that could identify as soon as I hear something, oh no, this is a gunshot. Oh no, this is a firework, you know? So there are some use cases or examples that we could be using deep learning for that could be helpful for our cases. But there are several ones. This is just one that came to my mind.
Muito obrigada. Temos outra pergunta.
Buenas tardes, muchas gracias. Mi pregunta es si en los modelos que tienen entrenados en la plataforma hay modelos para hacer un procesamiento de lenguaje natural, pero en español. Y si no hay en español, ¿qué recomienda en donde se pueden donde podemos encontrar corpus semánticos o modelos preentrenados para hacer analítica de texto?
Então, ele pergunta se na plataforma tem modelos...
I think I got it. Yes. No, we don't have in a different language other than English. We have one model that is trained in Chinese. I don't think we have any model that is like using as either like other language other than English, like Spanish or Portuguese corpus. But I know there are places where they are more focused on those languages. I would try to do a search. I cannot think of like any place in particular. I know that TensorFlow, for example, not only the tutorials, but they try to be more, you know, to expand, to not be only like working with English use cases, but like different use cases. Even like the tutorials, they also are looking for contribution to translate tutorials from different languages. But in our project, if you are interested, that's something that you can contribute. Like, can we expand this to different languages, right?
Bueno, la última pregunta para poder continuar.
A mí me gustaría saber en sí qué metodologías abarca lo que es el deep learning y cómo este se diferencia más que todo de lo que es el machine learning y el statistical learning. Porque hasta donde yo entiendo el deep learning, como yo lo he podido entender, simplemente abarca como las redes neuronales y como todo lo que deriva de ellas. Entonces me gustaría saber realmente cómo se diferencian todas estas corrientes que últimamente están tanto de moda.
Tá. Ele deseja saber a diferença que existe entre Deep Learning, Machine Learning e Statistical Learning. Ele percebe que as redes neurais são a principal aplicação de Deep Learning, mas fazem parte de todo, ou tem uma fronteira bem delimitada para diferenciar eles.
Yeah, that's a very good question. I think the main difference that I can think of is the amount of data. It's how, like, to do deep learning, usually you need to have large amount of data. Some domains, as I mentioned, it's going to be harder for you to use the regular machine learning concepts. Which deep learning, it is a machine learning technique, but you use several layers. Actually, deep learning or like neural network is nothing other than like kind of like a linear regression, but it's like layers and layers and layers and layers. It's an interesting, there is a talk that I gave where I explain, you know, what is a deep learning and how it relates to statistics or linear regression. And I explain the whole concept. So the main thing is around the amount of data and then specific domains. Like images is a computer vision, right? It's a domain that I like to mention because it's pretty much only possible with deep learning.
Muito obrigada.
Bueno, muchachos, le agradecemos a la profesora de Queiroz por acompañarnos en esta conferencia y seguiremos pues con las otras conferencias. Ahí les quedaron los datos de todas las redes sociales y mail de ella para próximas dudas. Démosle un fuerte aplauso en agradecimiento a...
Muito obrigada mesmo, viu?
Muchas gracias. Muchas gracias.
Muito obrigada, professora. Ah, sí ve, es que las mujeres de la ciencia somos así.